Hello everyone, this is Rafi here, and today I'm going to demonstrate a small piece of lab where I'll be configuring NAT Failover, and we'll see what happens actually in NAT Failover scenario. So for that, I have taken an internet router, as you can see here, right here, and it's connected to two different ISPs, ISP1 and ISP2. ISP1 will be considered my primary ISP, and the ISP2 will be my secondary ISP. And there in the top drop down, you can see the FortiGate firewall that I will be using to filter my traffic, and and down there is a L2 switch, and user is connected to that switch. So already everything has been configured, including the IP address on FortiGate firewall and the policy needed to allow the internet at the same time to and the IP configuration, ISP configuration, ISP IP configuration, and NATing. Everything has been done. Every configuration has been done on my internet router. So let me log into my internet router first. That's my internet router. And if I check show IP interface brief, as you can see, gig 0/2 is my ISP1, and the IP is assigned 103.11.11.11, and the ISP side IP is 11.12. If I try to ping my ISP, it would be reachable. As you can see, the ISP is reachable, and if I try to ping 8.8.8, that is also reachable via ISP1. And if I take my routing table show IP route static, as you can see, currently the traffic is going via my primary ISP, which is the ISP's next door. And similarly, I have configured the secondary ISP's IP as well. And on interface gig 3, that is my secondary ISP, and the IP for secondary ISP is 203.22.22.22, and ISP side IP is I guess 23, I guess, yeah, and that is also reachable. So we have already configured the NAT configuration here. So let me show you the NAT configuration. Show RAM pipe section NAT. If you check on the NAT configuration, yes, the NAT, since I have dual ISP connected to my internet router, so I have to configure the NAT twice, and I have done it using a route map. I have created a route map for ISP1, and I overloaded it to ISP1 interface, and I have created another NAT rule that is where I used the route map ISP2, and where I used the interface, associated the interface of ISP2 as well, and overloaded it. If you want to take on my route map, show route map, you'll be able to see two route map is created to associate to different ISPs. This route map is for ISP1, where I have associated the access list, which is called named by internet. I will be demonstrating you the access list either where what address I allowed to go to the internet, and this is the interface I have associated. This interface is for my ISP1. I have associated gig 0/2 for my ISP1, and I have associated gig 0/3 for my ISP2. That's the route map for ISP2. And I have associated the same access list on both this route map. So let's go and check out what this route access list contains. As you can see, this is my access list, internet, and I have permit these IPs. This is my local IP that will be going to the internet. Actually, I have configured, this is not the actual LAN IP addresses. If I log in back to my FortiGate, let me show you the configuration here on my FortiGate. This is my LAN PC, which will be accessing the internet and will be performing the test on this machine. First, let me show you the configuration of my interfaces and policies. I'll be showing you all. Just hold on a sec. So coming down to the network section and then interfaces, let's verify the configuration of each interfaces. Let me show you the topology ones. As you can see in my FortiGate, port 1 is connected to my internet router. That means this is my outside interface, and port 2 is connected to my LAN switch. That should be considered my inside interface, and I have configured the LAN subnet, which is my PC's gateway here on port 2. As you can see in port 2 configuration, I have configured my LAN subnet, which is 1099.80.1 and /24. And if I show you the configuration of my outside interface that is connected to my internet router, that is port 1, and that's the port 1 configuration. That's nothing but a transit IP point-to-point which is connected to my internet router. And here in my FortiGate side, I have used 10.127.127.1/29, and I use 127.2 on my internet router. That's all, and I have configured a default route towards my internet router here on static route to access internet for my LAN users. At the same time, I have configured a policy, a must needed policy to allow internet for my LAN subnet. I'm sorry for the inconvenience. The browser has stopped responding for the time being. That's the reason why it's taking a few time. So let's get it some time to respond back. I'm sorry for the inconvenience. My browser got tagged and it took a little while to respond back. So we are getting back to the static routes. That's the route I have configured towards my internet router. That's the IP of my internet router, and I have already configured everything. Everything has been pre-configured, because if I want to configure everything from the scratch, then the video will be too long and it's really hard for you to watch till the end. So that's the reason I configured everything earlier, and I'm just demonstrating you what all I have configured here. So now I'll be moving into the policy. That's the policy I have configured here. As you can see, the policy named to it internet allow. Here the source address is my LAN block, which is 1099.80.0/24, and the destination is all. The schedule is OS, and I have allowed all the services. And here one thing I would like to mention you, I have NATed my LAN IP. I have NATed here with this block 192.170.177.27 to 28. I have created a pool, NAT pool, containing these two IP addresses. I don't want to expose my local LAN and to my internet router. I don't want to advertise my local LAN network to my internet router. Hence, I have used this NATed IP here, and I crafted a NAT pool here and associated that NAT pool with this ACL. So given the fact that I don't need to configure my LAN block, which is 1099.80.0, or to my internet router. So if I go back to my internet router, and let me show you here the configuration of my, so here you won't find my local LAN block here, which is 1099.80.0. As you can see, the subnet is not in table. So instead of that, what I have configured here, I have configured the route which is on my NAT pool, that is 192.170.177.27 and 28. This route I have advertised here using a static route towards my FortiGate firewall. That's the next step. So that's how I have configured the routing, and since the route is on the table of my internet router, and if you take on my access list which I created to allow internet access, there as well you see only my netted IP, which is 192.170.177.27 and 28. These are the two IPs that I have allowed to access the internet. And as I have shown you the NAT configuration, once again I'm showing you the NAT configuration. So that's my NAT configuration, and I have showed you the route map either earlier. So now if I try to access internet from this piece of machine, let me show you the IP config of this specific machine. The IP assigned to this specific host is 110.99.80.101 and the gateway is 1099.80.1. So if I try to ping to the gateway, I think it should be reachable. The gateway is reachable. Now I will ping to the internet, that is 8.8.8, and as you can see the ping to my internet is working. So if you check on the log of my FortiGate firewall, then you see my traffic is being forwarded and it's allowing my traffic towards internet. Though it's taking a little while, just stay with me. As you can see on the log file that my source, this host machine is trying to access internet, which is 8.8.8, and it's allowing the connection. It's allowing the connection. And it's hitting the policy that we created. That's the only policy that exists on my firewall. So now what happens there? What is the issue in NAT failover that we often encounter in our daily life? That's what I'm going to demonstrate you right at this moment. As you can see, the internet is reachable via this ISP1. As you can see, the default route currently is configured towards ISP1. At the same time, I have configured another default route towards my ISP2, extending the administrative value, AD value, since I don't want to load share here. So that's the reason why I configured the administrative value different to ISP2. So as you can see, that's the default route towards my ISP1, and that's the default route towards my ISP2. And I have configured the AD value 10 here, so the lower administrative value will be installed in the routing table. So that's the reason why all the traffic is going towards ISP1. As long as I will down this ISP, I will down this link of ISP1, the traffic will be shifted to ISP3. Let's do that. So go to config T, go to my primary ISP link, that is my gig 0/2, and if I shut this interface down, you would see that the route has been shifted to as you can see, the default route has been shifted towards my secondary ISP. So since the NAT failover is done as well, so what we can expect here, we can expect that the internet should be allowed here. So my host machine should access the internet, right? Since the default route has been shifted towards my secondary ISP and I have configured the NAT failover either, if you check the NAT configuration again, show run pipe section NAT. As you can see, the NAT configuration for my secondary ISPs exist as well. That's there. Even so, the ping is not working towards 8.8.8. That's the trouble we often encounter in a failover scenario, that if the primary ISP goes down, your traffic, you should expect that your traffic should be forwarded by your secondary ISP, but that's not the thing we are achieving here. So that's happening due to a thing, that is, this NAT configuration is holding the old NAT table. Let me show you that. This is the NAT table. This is the old NAT table that is holding here. The old NAT table still holds here. That's the reason why it's not allowing the host to access the internet. So if I clear the NAT table using the command show IPNAT translation off, and you see the internet is accessible once again. So whenever I clear the NAT table, the internet is accessible. Again, if I bring the primary ISP off, interface gig 0/2, and I type the command no share, and you'll see my primary ISP is reverting back. As you can see, the default route has been shifted towards the primary ISP. Since the primary ISP is reachable, I have bring back the interface. So the route is shifted, but still the NAT failover is not happening. Yeah, though the NAT failover is happening, show IP NAT translation, you can see still the old entry is holding on the NAT table. So again, we have to manually, if we clear the NAT table manually, the ping will again work. As you can see, the ping is still working. So that's the trouble, and you can say that's the problem we often encounter in NAT failover scenario, that even if we configure the NAT failover for our secondary ISP or for our primary ISP, but whenever the ISP goes down or the primary ISP becomes unreachable, the traffic shifts to the secondary ISP. The default route shifts to the secondary ISP, but due to the old NAT table, it doesn't work. The NAT doesn't work. The user cannot access the internet. So that's the reason why we are clearing the NAT table. And in a production environment, or for an enterprise organization, for enterprise network, for a large enterprise network, it's really hard and difficult to identify the reason or to identify when the ISP is going down. And it's really hard to manually clear the NAT table every time, right? So what can be done to mitigate this, to overcome this inconvenience? So there is a tool inbuilt in Cisco that is called Cisco Embedded Event Manager, that is Cisco EEM. That is a scripting tool that allows to take certain action based on certain events. So we will be configuring Cisco EEM, Cisco Embedded Event Manager, to automate the process, to automatically clear the IP NAT transition table from the router, so that if any ISP, my primary ISP, goes down, then automatically the NAT table will be clear and the traffic will be forwarded towards my secondary ISP. Similarly, if my primary ISP gets back, then the traffic, then again I will clear the IP NAT translation table and I will shift my traffic towards my primary ISP. So how can that be done? So let's get started the configuration of Embedded Event Manager. So in order to configure Embedded Event Manager, first we have to define some sort of events that when the Event Manager script or that command will be triggered. So we have to specify and we have to define when that action or that event will be triggered. So That can be done in several ways, whether we can use the show or whether we can use the syslog events to trigger that action, that command that we want to execute, or we can use a track. We can use a track. So here in this video, we are going to use a track towards ISP1, that we will configure a tracking towards ISP1. If the ISP goes down, then the track will goes down. So as long as the track will goes down, the traffic will then the action will take that. It will clear the IP NAT transition table, and again I will take another action, that is once the the track will back to up state, then again it will clear the IPNet translation table. So in order to do that, we have to configure SLA, IPSLA. Let's configure the IPSLA, IPSLA1, and we want to track our ISP1 IP address, which is 103.11.11.12 is my ISP size IP address assigned to ISP router, and the source interface will be my gigabit 0/2, and the frequency will be 5 seconds. Exit IP SLA schedule IPSS schedule start time now. IPSL schedule, life will be forever. And the start time will be now. The SLA will start now. This command will start the SLA now, and the life will be forever. Then we'll configure a track 1 IP, track 1 IP reachability, SLA 1 reachability. So we have configured the track 1, and if we verify the track configuration with the command show track, and as you can see, the track 1, the IP reachability 1 is the IPSLA 1 reachability, the reachability is off, the track is off. Now we'll be configuring the event manager, the EEM. In order to do so, let's go to the config T, event manager applet. Let's give it a name. The name will be failover, ISP1 failover, ISP1 failover, and we'll use event track event status. We'll be using event status, event track state down, event track 1 state down. So the first event manager applet, we are configuring the ISP failover. When the ISP will fail, when the ISP will unreachable, then the track will be down, right? So once the track will down, then it will take the action. Now we have to define the action, since that's the event. When the track will go down to straight down, then the action will take action 1.0 CLI command. It will run this command, clear IP NAT trans, and the second action is, that's the action. and we will configure another event manager applet. When the failover will happen, when the ISP will get back, when the ISP will come online again, then again we need to clear the IPNAT translation table, right? So for that reason, we'll be configuring another event manager applet, ISP1 failback, ISP1 failback, and here also we will use the event track1 state off. When the track1 state will off, then it will take the action, which is to 1.0. Let's CLI command will give, first command will give enable, and action, the second command it will run is clear IPNAT translation exit. On the first one, I think I missed the enable command. Let me go back to, in the fast applet configuration, I guess I missed the first action is enable. Let me remove the first action, which was action 1.0 CLI command clear IPNAT translation. Oh, sorry, I started. First, I need to log into the event manager applet configuration, that is event manager applet ISP1 failover. Let's log into that, then I'll configure. Then I'll remove the action 1 and I'll place it to action 2. The first action would be enable, command enable, and the second action would be 2.0. The CLI command it will execute is clear IPNAT translation. Okay, well done. So if we verify the configuration, so of our event manager applet, should run 5 section event. So that's the event manager applet configuration we have performed. The first one is for the ISP failover. Whenever this primary ISP will goes down, then the track will be down, right? So once the track will be down, it will perform this action. First, run this enable command, and second, it will run clear IPNAT translation table. And then again, when the ISP1 will come online and get off, then the track will off. And once the track will off, then it will execute this command enable and clear IPNAT translation. So let's verify now. So if we log into that host machine again, sorry for that. So as you can see, the ping to internet, it's still running, right? So let's keep it on the left side open, and let's turn off the ISP1, shut down the ISP1 interface. So, oh no, I'm sorry, that would be gig interface gig 0/2. That's my ISP1, and I'll manually shut down the ISP. And as you can see, I have turned off the ISP1, and the track will goes down. Yeah, you can see the track goes down. It's stayed on to down, and you can see earlier, whenever I was shutting down the primary ISP, then the ping to the continuous ping towards the internet was stopping, right? due to clearing the NAT translation table. But this time it just lost 2 packets, and then again the ping started running. So that's the thing that we automated using the scripting tool Cisco EEM. And let's do the same for failback. So let's fail back the ISP1, and whenever the ISP1 has failed back, again the truck now the truck will off now, and as you can see the ping is lost, 1 packet is lost, 2 packet is lost. So now the truck is off and the ping is back again. So that's the configuration that I wanted to demonstrate you. The users of Cisco EEM Event Manager, Cisco Event Manager, Embedded Event Manager. That's how we can automate some sort of action based on some sort of event that we can define. Like here I have taken the truck event, like if the truck goes down or if the truck goes off, depending on that event, the action will be executed. But you can take others even as well. You can even take some syslog pattern, or you can take some other event type to execute a specific action. So I hope you have enjoyed the video. So that's all, and thanks for being.